Okay, let's talk about encapsulation. So, we have our example, class car and transport sim over here. Encapsulation means you hide the information so that your user cannot know something that you don't want to, or you prevent your user from overwhelming information. Okay, so let's say I want to use my car in transport sim program. So I can use it by, let's say, I want to change the speed of each car. All right. So I can do it by doing a direct access. Right. A.speed means the speed of data A or the speed of object A. A.speed equal to 100. I can set it like that. But I can also do something that the creator of class car did not intend or did not want me to do. Like B.speed equal to minus 100, something like this. The creator of class car, in fact, doesn't want the speed and the acceleration to be negative. So I, the user, am violating what the creator of class car wants. Okay? But the creator of class car, for now, cannot do anything with what I'm doing. Alright? To prevent me from accessing the information incorrectly, the provider of class car must do some encapsulation on variable speed and acceleration. Alright? So to prevent speed from being to be, modified to any value, I, as the creator of class car, can do something like this. Private int speed, private int acceleration. Alright? So by making my variable private, we call private and access modifier. Alright? There are several access modifier. Alright, we have private, public, package. Alright? So now that I make speed and acceleration to be private, you can actually see that it's not visible in transport sim anymore. Right? Speed has private access, so it can't be accessed using the dot operator or using this direct access from now on. So this prevents the user from changing the value to anything. Alright? But it also prevents a user from changing the value at all. So right now, the program doesn't work at all. Alright? So my encapsulation is not complete. Alright? Not yet. So what I do is, to prevent illegal range access to my value, I changed my data to private, but I also have to provide a way for my class user to change the value. All right. But in a way that I can control the change. Okay. So what I do is I will create what we call getter and setter. Okay. So right click and then generate getter and setter. I'll generate both. All right. And there are templates that you can choose from, but I'll leave them at default. All right. So the generation of speed and it hasn't done for acceleration. So I can do it again. Right. Now I can choose acceleration too. Okay. So now I can create get speed and set speed and get acceleration, set acceleration. So the user now can use method to change the value. And since they can use method, but not direct access, we, as the class provider, can write things in the method to control the range of value. Okay? So in set speed, I can actually control the range of value if speed is less than 0, then I'll do this dot speed equal to 0. Oops. Else something like this. All right. So I can actually replace with max, right? But I think I'll do it like this for now. I think it's easy to understand. So if the given argument speed is less than 0, then the speed of my object will be set to 0. Otherwise, the speed of my object will be set to the argument speed of the method. All right. So this way, I can make sure that speed never go to negative value. Okay. Right. And the same can be done for acceleration. So let's just complete it. All right. If tag less than 0, then this dot tag equals 0. Otherwise, this dot add equal to add. All right. And remember, this dot add and add that you use as the method argument are different things. All right. In add here, well, it's a method argument. All right. But this dot add is the acceleration value of this object or of the current car object that is executing the code. Okay. So it belongs to the car. This dot add belongs to the car. So it's here. This dot add is the property of the car. But add here is just a local variable of your method. All right. So once you have defined your getter and setter, so this is getter, just read the value. Well, if things are private, we have to make both getter and setter. All right. So although the code doesn't do much, we have to create it anyway. Okay. So to use it, I can call the method set speed 100 like this. And B, I can do set speed or set act. Okay, I'll just use speed. Right? So I can set speed to minus 100. The user can do that, but the creator of class car has already prevent the value from going negative. Alright, so if we print the value out, let's print system carry me system dot out dot print a dot get speed. I can't use a dot speed for reading the value. Alright? It's not visible since it's private. Private variables can only be seen inside the class that owns it. Okay? So, can't be seen outside now at all unless we access it using method. Whoops. Type. So print speed, a.getSpeed, and print b.getSpeed. Right? Okay. So, let's run it. But to be able to run it in a Gradle project, you have to tell Gradle. So, go to view.gradle and change the main class to transport sim. Object code. Well, let's see. Okay. Transport sim is in folder object code. So I will change this to transport sim. Transport sim. Alright, so you have to tell Gradle about your main class. That's all. So now, maybe you can refresh Gradle. Okay. After we refresh, we can clean the source code, the machine code, and then start compiling. Oops. There were failing tests. Okay, that's fine. In the example, I intentionally made one test fails. Alright. So, but we're not looking at that for now. So the compile should be fine. I'll just close the Gradle for now and run transport sim to see what value I get for the speed of A and B. That's right. See? And is setting his speed to 100, so it prints 100. B, the user is trying to set its speed to minus 100. And, well, we already prevent negative value in our set speed, so the value comes out could be 0. All right, so that's encapsulation. All right, and in the example here, the encapsulation is done in order to protect the access of variables. All right, so user only need to know that they can access or change values by calling methods. All right, so that's the only way that the user can modify any values. All right, in other words, from now on, the user doesn't need to know the inside workings of our class. All right, they only need to know how the method will return values. All right, so they only need to know which method to call in which situation. All right, and for more complex program, this will help a lot for both the class provider and the user of your class. All right, since the user doesn't need to know everything now, they only need to know methods. All right, and don't need to know the inside workings of the methods at all. Okay? All right, so that's encapsulation. All right? Okay. In the next video, we will be looking at abstraction and one example of abstraction, that is inheritance. All right? Okay? So, see you in the next video.